I just want to quickly talk about comparing strings. So we did it in the beginning. We talked a little bit about strings using equals and not equals. So S equals Greg. We can also access the individual elements of it just like a list. Notice how I'm just accessing all of the individual indices, just like an array. So it has indexing. I could also grab a sublist 0 to 2, so I can slice it 2 to the end, or 1 to the close to the end. There's actually only 3 in there, so I probably should have done S1:3, is what I meant to do. So we can slice it, we can get index of it. We could also ask if something is inside of it. Just like we can do, so we can test membership. So we can do all the same operations with indexing, slicing, and membership with a string. S0 equals, I don't even have a good thing. Ooh, let's do 2. So it doesn't allow us to change it the other way though. So this part is different. It doesn't allow us to do item assignment like we were able to do up here. So you cannot modify the contents of a string, but you can return it through an index. And then going back to comparisons, and we are out of time. So I can check S equals Greg is true. S equals Bob is false. S not equals Bob is true. And you can also sort them or look at them what's called lexicographically. Is S, which is Greg, less than Bob? No, because B comes before G. However, lexicographical, what that really means is that capital letters are actually smaller than uppercase letters. So we have S, and S1 less than S is true. I know it seems weird. They basically have the same letter, except capitalization is different. And then you also have less than equal and greater than equal. So you can do kind of comparisons, just like you do with numbers, but with strings, in which checking to see if these characters, again, capital letters are smaller than larger letters, but it's checking the alphabetization inside. No, it compares the whole thing. I just did the first letter because it's easy. So S and S1. What if I set S1 equal to Greg? Actually, yeah. S1 less than S is true, which is weird, but the reason it's true is that the G in Greg is greater than the E in green. And then S equals dog. S1 equals dog bone. Now S is less than S1 because they have the same first 3 letters. So the longer one is considered larger. So that's another thing when doing character by character comparison. It is doing a character by character comparison, yes. It's equivalent to something like this, which would be terrible to write. It's something like that. In fact, I think I meant to do something like that is kind of what it's doing. I'm not sure why that's not working all of a sudden. But okay, I use less than. It would have been equivalency for the other thing, but that's what it's checking, right, for equality and such. Yeah, capital letters, it's actually based off ASCII or the Unicode table, but technically the ASCII table. Capital A actually has a value of 65. Lowercase a has a value of 97. And then it goes all the way to capital Z is like 90. And lowercase z is like 122. And numbers are like 0 through 9 are somewhere in the 40s. I don't remember exactly where they are, but there's some, and even spaces technically have, spaces are like 32. So it's ASCII table. And when we say it's lexicographical, it's alphabetical within these groupings, but it's lexicographical because it's based off the ASCII table. It's based off the letters number when it's actually doing the real comparisons. So that's why you compare lowercase to uppercase, and even compare them to numbers if you really, really wanted to. But that's a very, 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 very quick introduction to letters and comparisons.